Hello, this is Steve Pegram here again with another short webcast on fibre and connectivity matters, and this time I'm going to discuss the differences between DSL, broadband, fibre and leased lines. So broadband then. Broadband effectively is designed, originally at least, to reutilise the copper network that was originally deployed by the Victorians, reusing that copper wire connection between your home or office and the central exchange for use to provide internet connectivity, which is then provided to you down that connection from the service provider's own internet backhaul connection. So here we have the telephone exchange, and there is the internet connected behind, and there is a connection between the exchange building and your home or office. So that is how broadband was first put in a few years ago now. Now, of course, the speeds that were achievable in those days were in the beginning quite low, and maybe half a meg or something of that kind. So we've moved on through 1 meg or 2 megs or so on until we come towards the end of what is possible using that type of network topology. To faster connections, where so-called super fast broadband or even fibre broadband, which I'll use the word in quotes, has begun to become commonplace, certainly in towns and cities, where you started to see these nice green cabinets, mostly green, deployed at the end of the street, and now your broadband connection is connected between your home or office and that cabinet, and from the rest of that connection that goes to the telephone exchange or whatever is provided on fibre and then onto the internet as before. Now, the reason why that's faster is because the copper wires section here is a lot shorter than it was in the previous example, which went all the way into the town centre. Now it generally goes as far as the end of the road, and therefore that bottleneck, which is copper, has been reduced in size, and it has a less effect, and therefore we can get much faster connections than we used to have, which compare very favourably with half a meg to maybe even 50 megs. I get about that in my home, and the street cabinet, so-called, at the end of the road is approximately 200 yards away, something of that kind. So the connection is still copper, but the backhaul connection now goes on fibre all the way to exchange and from thence onto the internet. So there we are. That's super fast fibre broadband, which is providing you a fast internet connection to homes and businesses. Now, the more fortunate of us may even have so-called full fibre broadband, whereby your connection is now all the way from your home or business to the central office of the service provider, wherever that happens to be, and spot the topology being similar again. The backhaul connection is then provided from that location onto the real internet, as it were, on the service provider's backhaul. So in each of these three cases, we have first of all copper, then copper with a bit of fibre, and then fibre all the way in so-called full fibre broadband, and that is the three examples of broadband connectivity delivered in that way, and they increasingly reduce the significance of the copper bottleneck. Now, that's all about broadband, so consider what that really means in practice as far as service quality is concerned. So the difference which we may want to consider is to do with how many people are using those connections at the same time. Now, in the early days when we talked about normal copper broadband, those connections are all multiply going from the home or office to the telephone exchange, and obviously there's a lot of connections going at the same time. There was also problems in the copper going further than just the pure distance, but also concerning the fact that they were all occupying the same physical cable in the street, and therefore were able to interfere with each other. So that's a further problem why the performance of this connection is reduced, is because not only is the whole system shared at the exchange, but also the copper wires are actually sharing the same physical cable in the street. So that's why the sharing reduces still further the quality of that connection. Now, again, coming to so-called full fibre, or rather fibre to the cabinet solutions, we still have some of the same thing going on. So again, the copper connections from your home or business are sharing the same cable, albeit a much shorter cable now. So there is still some sharing going on, but obviously that is reduced as far as the backhaul connection is concerned. But the interesting thing is to consider the fact that so-called full fibre broadband, although there are separate fibres going from the home or business to the central office, they are still, when they come to the exchange, are still being shared amongst the equipment that sits in that office before it can go into the internet backhaul connection. Because these connections, even though the performance of down here we may have been thinking about half a meg or so on, and over here we may be even talking possibly even as high as 1 gigs. So clearly as a much faster connection is being provided in each of these cases as the evolution has continued. Nevertheless, because the connection is shared, the ultimate backhaul connection is the bottleneck is now somewhere in the exchange building and maybe even the service provider's backhaul connection. So there's always going to be a bottleneck somewhere in that equation, and it merely is a question of where that is. And the effect of that bottleneck is to degrade performance, especially at peak times, and reducing the bandwidth, and also degrading jitter and latency performance, which is a serious issue depending on what kind of service you're actually trying to deliver. But of course the service that's being delivered is defined by the service provider to perform as they wish it to do. And that's the crucial thing about all three of these types of broadband connections. Now, compare that with a leased line connection. As I've said a minute ago, broadband can be delivered on copper all the way, copper plus fibre, or fibre all the way. In each of those three cases, it goes to a exchange building, and that's where a bottleneck will exist inevitably, where there is a connection through to the internet at large. Now, consider that in comparison with a leased line. A leased line is qualitatively different from a broadband connection because it doesn't go to the exchange building equipment. It is basically designed to provide a connection between one premises belonging to your organisation to another premises belonging to your organisation. And that's all it does. It provides that connection at whatever speed you've actually asked, you've procured. It could be 1 gig, 10 gig, 40, 80, 100 gig, or even more. And that is purely dedicated to you. Because of that, there is no contention, there's no sharing, there's minimal latency, and it behaves much, much, much more quickly than even the fastest so-called full fibre broadband, which may operate at 1 gig if you're very, very lucky, through to 10 gig, 40 gig, 100 gig. And that's the sort of connection you're going to be using if you need to have for example, a data center connection, or even connection between maybe hundreds, dozens of users who are all doing things that are specific to your business. And before I leave this slide, I will just mention, of course, that a leased line, although it doesn't require the internet to be provided to make it work, it can still play a part in an internet connection, because in that case, a local building could be connected to a remote building, and that remote building could itself have an internet connection, so that in that way your internet connection is coming down your leased line. So there is a little bit of a blurry line between the two things, but the basic principle is that leased line connections do not require the internet at all. So a leased line provides a connection to a remote site, and that remote site could be another building, or it could be, for example, a data center building. So that, of course, is another type of building, but the distinction I'm drawing there is a building with people in it and offices and so on, and one which is basically a bunch of servers. So the principle there is a small difference, but the topology of the network is the common one today, where we have a separate data center building, and that would be your private cloud. And it may be hosted for you, or it may be your own premises. It doesn't really alter the logic of this diagram. So that's two leased lines connecting together via a data center, or two buildings being connected together directly as you wish, and the difference is a very small one. So A remote access to a leased line facility, to a data center facility, does not require internet connection. However, if you also want an internet connection, that doesn't preclude you from having an internet connection as well. Similar to the earlier slide, in this case, we have a hybrid cloud setup where we have the local private cloud data center facility here, and that is also connected through to the internet, where you may have remote public cloud services such as Google, AWS, Azure, etc. So there again we start to see some blurring of the lines between what is private, what is public, but the basic principle again is that a leased line provides you dedicated, uncontended, unshared private connectivity across your business network through to either your data center facility or your data center and public internet connection and public cloud solution. So there we have a private cloud and a public cloud in the two examples. Now, what else can a leased line do? Of course, you can build entire networks from leased lines. It could be, I showed previously, only 1 or 2 buildings, but it could be 4 or 5, as shown in this picture here, or it could be dozens. And there may be reasons for wanting to do that. They could be regulatory reasons, they could be privacy reasons, they could be corporate policy reasons, or just simple network performance reasons and cost reasons. So if you have an internal network that's operating at 10 gig, for example, that means all your users can be communicating with each other over an incredibly fast connection. Computer servers and so on can all be operating, software applications can be all operating over extremely fast connections. And taking the previous example where there was a internet connection, yes, the traffic can pop out into the internet if you really need it to, but it certainly doesn't require to go to the internet to make it work. So in this case, you've got a private network is dedicated specific to your organization, and it's not using the internet unless you need it to. So, conclusion. A leased line is a high-performance direct connection to another site that bypasses the internet. It's better for security, it's better for performance in many ways. Leased lines are normally delivered on fibre, more of which we'll speak about on another occasion. They can also intersect with the internet, but they don't need to. So the crucial point is that the performance of this network, which is dedicated to you, is far, far better than you will get from any broadband internet service provider. So this has been Steve Pegram telling you about all that at Sorrento Networks, and I hope you'll join me on a future webcast where we'll discuss more elements of this overall optical networking story. Thanks very much. If you want to find out more, you can contact me, of course, or you can visit our website at www.sorrentonet.com or email us at sales@sorrentonet.com. Sorrento is part of the Comtech Group, based in Deeside in Wales and at Belfast in Northern Ireland. Thanks very much.